Okay, well, let's go ahead and get started. So I've uploaded this onto CCLE, this the Stats 15 lecture, Week 2, Lecture 2 Wednesday, dplyr demo. You can download that. All right, now we left off on Monday, and we didn't finish the lecture. We got to, I think we left off right after mutate. Mutate is used to kind of create new variables, okay? Looks like most of you guys brought your laptops. If you don't have a laptop with you, sit next to somebody who does, maybe, if you're willing to. If that person wants you near them, okay? If they don't want you, then, respect each other's personal space too. Okay. So I want to talk about group by and summarize before we get into this. Well, I don't know. Maybe I'll save this until we get to the group by and summarize parts here. Okay, so let me have you guys go ahead and fire up RStudio. Download that R script, and then and open it up. And it should look something like this. Is this kind of what it looks like? Okay, and just so you know, basically I'm copying this straight out of this textbook, R for Data Science, another excellent resource. And in RStudio, you can hold down the Shift button and click any URLs, and it will open up the web browser. Okay. So this is from the textbook R for Data Science, and again, you can purchase the textbook from O'Reilly, the print version, but the entire contents is available online. And we are going to look at Chapter 5 on data transformation. And pretty much all of the examples that I'm using today comes from this chapter. And this other person, Jeffrey Arnold, has created some exercise solutions, okay? And again, don't let the fact that these exercise solutions be a hindrance. They're here to kind of help you. And again, I don't know how much time you guys have, but if you do have the time to kind of read through Chapter 5 and work through the exercises, I strongly encourage you to do that. Now, some of these exercises are a lot harder than others, but those are also kind of like going to the gym and just pushing yourself to do that difficult exercise. And if you're able to pull it off, you'll feel good about yourself and you'll become better, right? And you can also try it, attempt it, struggle with it. Maybe you don't make it through. Maybe you don't figure it out. Sure, then you can take a look at the solutions and see, oh, what was I supposed to do? Okay. But if you go straight to the solutions, as soon as you get stuck, then you're not really working on the problem-solving part of your brain, okay? Because just as important as remembering the commands is being able to kind of piece together the different functions, different things, putting them together in order to figure out your solution. All right, so first things first, we need to load up the New York City Flights 13 and tidyverse libraries. Now, there's a good chance that as soon as you opened up the R file, a little yellow bar at the top popped up that says, this needs the NYC flights thing. Do you want to install it? You can go ahead and click install, and RStudio is smart enough to say, to recognize what packages you don't have, and will recognize that you need to install it. So if that thing popped up, go ahead and click install. If for whatever reason you dismissed it, you can type into the console install.packages. And when you do install.packages, always put in the name of the package in quotes. I'm not going to do this, but I'll type it out. NYC Flights 13 in quotes as far as install.packages. Okay, and you'll execute that command. Okay, so one thing about navigating through an R script or even an RMD file is you can go down each line, okay? And you'll hit Control or Command Enter, okay? So my cursor is on line 12. I hit Control Enter, and you can see that it sends that command down into the console down there, and it executes the thing, okay? So NYC flights, that library has now been loaded. Yeah, question?
When I do that, it says there's no package called. Do I have to like?
So you have to do, if you don't have it, you have to do install.packages. Again, so I don't know if when you open that file, did a little orange bar at the top pop up that says you need to install this thing?
Oh, no, I don't recall.
Okay, all right. Well, then what you need to do is inside the console, you're going to type in install.packages parentheses and in quotes NYC flights 13. Okay, the exact name of the package. Okay, and you only need to install it once. You can also do it again if you get information that there's an update or something like that. All right, and then so after hitting Control Enter on 12, the cursor automatically moves down to the next line, and I'm going to hit Control Enter for line 13. Okay, and now it's loading the tidyverse. The tidyverse is a fairly big package that takes like a moment to load. Okay, let's just pause here and make sure everybody's got NYC flights and the tidyverse package is loaded. All right, let me know if you're encountering any issues with this so far. Yeah, question or issue. Okay, so maybe you start RStudio and then just open the file within RStudio, and then probably at some point you have a PC. We'll have to change. Yeah, we'll have to change the default settings so that .r file will open in RStudio. Okay, but open up RStudio and then open it up. Okay, is everybody good? NYC flights, tidyverse good? Anybody not good? Yeah. Yep. Okay, yeah. Wait. Let's see. Did you start off with a new session? Okay, yeah. You loaded it earlier already. Okay. All right, if everybody's good, let's go ahead and take a look at the flights data set. Okay? The flights data set is just in a table called flights. Okay? Now, right now, I want you to know, so in my corner up here, it says environment is empty. Okay? Or it should be. Oh, here, let me tell you one thing, okay? This will save you a lot of heartache, okay? So if you go to Tools, go to Global Options, all right? And under General, there's a few settings I want you to set, okay? I want my stick. All right, and, okay. So, one, this thing, restore, okay, this should be unchecked, okay? All right, so this restore our data needs to be not checked. Save workspace to our data on exit, never, okay? Workspace, nothing. Save, unchecked, save workspace, never.
How do we get to those options?
How do you get to the options? You're going to go to Tools, up in the menu, Global Options. Tools, Global Options. Restore our data, unchecked, save workspace, never. Okay? Why? Okay. Because I think the default is when you exit, it saves what you're working on. All right? And you're like, oh, I want to do that. That seems good. Okay? Well, the problem is you're going to get stuff in this environment, right? And you're going to load it up and stuff will be in your environment. Sometimes you'll have libraries and stuff, okay? And sometimes when you have a library installed or loaded, it changes the behavior of certain functions, okay? Like, for example, when you load tidyverse, there's a function called lag, okay? And when you load tidyverse, it gives you this warning. It says conflicts, okay? And that's because tidyverse contains its own function called lag, and that basically, what it says, masks the original lag function, okay? Now, if you work by yourself only, ever, maybe that's fine. And you go, oh, every time I use lag, it's always going to be the tidyverse lag. But more likely than not, you're going to have to work with someone else. Maybe in a group project, maybe at work, you're going to have colleagues, unless you're running your own cell phone company where it's only you all by yourself all the time. But most likely, you have to work with somebody else. And if your script is expecting this, but the other person's computer is expecting the other kind of lag or something like that, you give them a script, it's not going to work, okay? And so by always starting off with an empty thing, this will force you into the good habit of making sure your script will work on someone else's machine that starts off empty, okay? And that way you can kind of save your script, give it to someone else, and just say, hey, make sure you start off empty, which is kind of the expectation, okay? You don't say, hey, make sure, like if you're expecting somebody's machine to have certain libraries loaded, that's fine, but just write that in your script, okay? Your script assumes it starts off empty and say, hey, load this library, load this library, load this library. It's not a good habit to say, oh, I'm expecting everybody to already have tidyverse loaded. Just call that in your script. Just write, oh, right in your script, line number 1, load up tidyverse, okay? Not a bad idea. And so I recommend this. Don't save your workspace on exit. Don't restore our data into your workspace. All right, so all right, we've covered 2 lines so far. Yeah, question.
Does that mean you have to reinstall tidyverse?
No, okay. You don't reinstall, you load it, okay? So it's the difference between, like, I don't know, you buy video games for your PlayStation or something, okay? You don't have to purchase the game every single time you want to play it, okay? You purchase it once, but then if you want to play it, you have to load it, right? You have to load it. And that's all we're going to do, okay? We install it once. You don't have to reinstall the game every single time you want to play it, but you do have to load it, okay, if you want to use it. And that's kind of what it's like here. You install the package once. Maybe if there's an update, you have to install an update, okay? And then every time you want to use it, though, you do have to load it, okay? And so you load the library, you load the package using the library. That will load it, okay? But you don't have to reinstall it every single time. Yeah, question.
Like a warning message saying the NYC flight is still under like R version or 0.5.
Okay, so that means you installed R on your computer a while ago, and it's an old version of R, and it says, hey, this new version, the NYC Flights is expecting people to be using a newer version of R. Maybe it's time for you to upgrade your R, okay? That's if you get a warning like that, okay? Okay, let's go ahead and take a look at flights, okay? So you hit flights, and now notice what happens to, I guess it doesn't load up there, but it pops up here, okay? Now, here's a couple important things. Right here, very top. The very top tells you the dimensions. Okay, when you're working with dplyr or working with the tidyverse and you have data sets that are tibbles, the dimensions pop up at the top. It says 336,776 rows, 19 columns. And it only generally prints what it can fit, okay? So here it says I have 13 columns here, and it says 6 more variables. It also just prints by default the first 10 rows, okay? Now, if you want to see more than 10 rows, you can do flights. Well, there's a few ways. Okay, so one is you can do print flights will give you the same thing, 10 rows by default. Print flights, comma, n equals, say, 30, will print out 30 rows here. All right, so the command being print the name of the thing, comma, n equals 30. Now we get 30 flights here. All right, what's in my data set? The data set, these are all the flights going out of New York City in the year 2013. So, January 1st, 2013, departure time 5:17 in the morning. The scheduled departure time was 5:15 in the morning. So the departure delay was 2 minutes. Okay? And this was leaving EWR, LGA, and JFK. So there's 3 airports in the New York City area. There's JFK, LaGuardia, and Newark, I believe. So, EWR Airport is Newark Liberty International Airport. It's technically in Jersey, but it's considered to be part of the New York City area, right? So here's Newark. Let's find JFK. Okay, well, too close, all right? Okay, JFK is over there. All right, so Newark is over here, JFK is over here, and then LaGuardia is up there, okay? So these are the 3 airports in the New York City area, right? So if you're gonna fly into New York, you're gonna be landing at one of these 3 airports, okay? And then you'll take a subway to get to wherever you want, okay? But anyway, so we're looking at all of the flights departing from New York, and there are other things like the destination that got left out of my thing. But we could see, okay, this one originated in Newark. Okay, carrier is UA United Airlines, flight number 1545. This is the airplane number. It was scheduled to arrive at 8:19 and it arrived at 8:30. So that constitutes an 11-minute delay, so on and so forth, okay? And it lists every single flight, and in the year 2013, and there were a total of 336,776 flights, okay? A lot of flights going out of New York. Okay, let's do a few things. So one thing is we could say, hey, let's just look at all the flights that left New Year's Day, right? So let's say you were taking a vacation, winter break in New York, and you say, all right, UCLA's winter quarter starts up January 3rd. I got to leave January 1 in order to get moved back into the dorm on the 2nd, and then start classes on the 3rd. Okay, so you can do that, right? So, oh, I'm sorry. So let me run line 21. We're gonna hit enter here, okay? And it looks like it's the same thing that got output, but it's not, because we can see right here how many flights we have. We have only 842. 842. Okay. Now, if you want to save this to work with it later, you can use this this symbol. Okay, or not? It's 2 symbols. It's the less than dash, but it looks like an arrow. And we could say take the output of filter flights, month equals 1, day equals 1, and assign it to January 1, okay? And we could see that in the environment, that gets saved, okay? It gets saved up there. But then, in the console, nothing appears. Nothing appears, right? So when you save something, nothing gets printed out into the console, okay? One thing, if you want to clear out the console, there's a couple things you can do. One is you can hit the little broom in this corner, or you see the keyboard shortcut, you can hit Control or Command L if you're getting too much stuff in the console and you want to clear it out, okay? And then your cursor pops up in the top left thing. So let's say you say, all right, let's take a look at all of the flights going out on Christmas Day, December 25th, 2013, okay? Let's say you want to save it in its own thing so you can access it later, December 25th here. And then let's say you also want to have it printed out. So one thing you can do is you can wrap that command where you save it, you wrap it in parentheses, and it will do the save operation and it will print it out for you. So you're going to hit Control Enter there. And we get that. We get 719 flights going out on, the month is the 12th, the day is the 25th. That's what we have. And you can see, you know, the flights, they go like right after each other, right? 5:42, 4 minutes later, another flight's taken off, right? And kind of during the peak times, it's like those air traffic control people, they're just sending airplanes off just right after another, okay? Yeah, question.
So, what's the difference between like if you just normally, let's say, filter and then put it like let's say in January 1st, and then like for the December 25th one, there's like a parentheses around the whole thing. So like
Yeah. So the whole thing there, okay, was that if you wrap your save command, so normally when you save it, nothing gets printed out. If you wrap your save command in parentheses around the whole thing, it will print out what you just saved.
Oh, because like when I did the control enter on the January 1st, it printed it out.
There's two. So line 21 doesn't save, that one prints out. Okay, here, let me just demonstrate again.
Oh.
So line 21 doesn't save, it prints out. But line 25, let me clear this out, line 25 saves it, but nothing gets printed out.
Oh.
Okay? All right, so here's a few more things that are very useful when you're using something like filter. So you want to say, I want all the months. I want everything from November and December. So you're going to say month. And rather than doing month is equal to 11 or 12, I highly recommend using the percent in percent. Month is in this vector of values. Okay, is one of the value, you know, either 11 or 12, or you can put however many numbers you want to put in there. 7, 11, 12, right? July, or November, or December, or whatever, right? So we can do that. And this will give me all the flights in November and December. There's quite a lot, 55,403. Okay? We have ways to kind of specify different kinds of conditions. Okay? So the ampersand is for and. The vertical bar, which is located above your enter key, and you have to hit the shift button, that is for or. Right? And the exclamation point means not. Okay? I think these are pretty standard, but if you've never taken a computer programming class ever, and we don't assume anybody has, that's how we would do something. Okay? So let's just take a look at, say, flights again. All right, and so let's say we wanted to look at the departure delay or the arrival delay, and we want to see, what would this mean? Line 39, filter flights. Okay, this says arrival delay, there's a not sign, not, and inside that there's parentheses, not parentheses, arrival delay more than 120 or departure delay more than 120. So that means we don't want flights that were super late taking off, and we don't want flights that were super late arriving, right? So give me everything that's not, okay? Or another way of saying that, okay? Lines 39 and 40 are equivalent. Line 40 says I want arrival delay less than or equal to 120. A comma is also interpreted as an and departure delay has to be less than or equal to 120. So basically all flights that were not delayed but more than 2 hours, all flights that did not arrive more than 2 hours late, okay? Arrival and departure delays are both less than 120, okay? And you can kind of verify that these two things are equivalent. We can take, hit enter on 39, 316,050, and hit command enter on line 40, and we get the same number result, 316,050, okay? There are a lot of missing values, okay? And this is one thing that is unique to R. In R, we have a specific value, NA, which is used for missing values. As far as I know, there aren't very many other languages that have a specific missing value. Python has nan, which is not a number, and we often use it as a missing value, but it's technically not a missing value. So anyway, anytime you work with a missing value, okay, missing value means the value exists, but we don't know what it is, right? So it's kind of just like, how old am I, right? Do you guys know? Maybe you know, right? Probably you don't, okay? How old am I? I have an age, okay? But you don't know it. So as far as you go, right, you'd write missing value. I don't know, okay? NA is missing, means the number exists, but I don't know what it is, okay? There's a different type of value, we won't get into it, but there's another value called a null. Null means it does not exist. Null does not, so if you say, how old is the professor's cat? Okay, well, I don't have a cat, okay? I don't own a cat, so there's no, the age of my cat doesn't exist because my cat doesn't exist, okay? Because I don't have a cat, okay? Whereas I have an age, you don't know what it is, but so you would use NA for my age, you would use null for my cat's age because I don't have a cat, okay? So anytime you do a comparison with a missing value, the answer is always going to be, I don't know, okay? So if we say, all right, you can think of inside this bag is a secret number, okay? That's going to be NA. You don't know what it is, secret number. And I ask, is the secret number, first question, is the secret number bigger than 5? What's your answer? Your answer is I don't know, right? So if you hit Control Enter on NA greater than 5, you get NA, I don't know. Okay, NA is basically a way of saying I don't know, all right? Is the number equal to 10? Is 10 equal to the missing value? The answer there, I don't know, okay? What if you add 10 to the secret number in here? What number will you get? Okay, all of these things, I don't know, all right? What if you take the number and you divide it by 2? What's the answer? I don't know, all right? And then here's another thing, right? So you can ask, is NA equal to NA? Right, NA equal NA. What's the answer there? Also, I don't know, right? It's basically saying, here's a box, we don't know what number's in here, right? Here's a separate bag, there's a secret number in here. Is the number in here equal to this number over here? And the answer is I don't know, right? So in all of these cases, we're gonna get NA. So don't do comparisons with NA, right? And then another thing that's frustrating sometimes, right? So let's say I create a vector x, all right? And it's got 1, 2, 3, and I say, what's the mean of x, all right? 1, 2, 3 adds up to 6 divided by 3. The mean is 2, all right? What if I say 1, 2, 3, NA? So x has the values 1, 2, 3, and missing. What's the mean of the numbers in x?
We don't know.
The answer is we don't know, right? Because we say, all right, I got this pet is 1 year old, the next pet's 2 years old, the next pet's 3 years old, and then we got a fourth pet, and we don't know how old it is. What's the average age of my pets? We don't know, okay? So if you ask, what's the mean of x, you're gonna get NA. Now, one thing you can do is you can say, you know what, please just give me the mean of the ones we do know, all right? So you have to say NA.rm equals true, all right? And here, because we're applying a setting, we use a single equals, okay? Double equals is a test of equality. Single equals says use this as the setting, okay? So here it says ignore the missing values. You got 4 pets. One of them you don't know how old it is, but the ones you do know, what's the mean? That's what we're asking here. So we say mean x NA.rm equals true. The default setting is false just to kind of make sure that it doesn't mislead you into believing that you know the mean when you have missing values. Question, yes?
Are objects methods to deal with NA values of each of them, like fill NA or drop NA?
Well, I don't know it.
Do our objects have like a fill NA or drop NA?
If we have NA.rm, which is basically ignore missing values, and we have ways to kind of deal with it. But Python has fill NA and drop NA, and basically we can do things where we filter based on NAs and stuff like that. Okay, so the way we deal with NAs, okay, we can't ask. So sometimes students are like, hey, I want to remove everything that's NA. I want to remove everything that's NA, okay? Don't do NA equals NA. Okay, don't do that, right? Don't say, hey, go through the column, and if it's equal to NA, get rid of it. Because equal to NA is never going to return true, right? Right? Your column might have values, 20, 17, missing, 5. And we can say, is it equal to NA? But basically, you're just asking, is 20 equal to the mystery value? Is 17 equal to the mystery value? Is the missing value, other missing value equal to this missing value? And the answer to all of them is, I don't know. And so that will never work, okay? So what we have to do is we have a specific function called isNA, and this will return true. Is.NA, and that's how we work with missing values. So I could say is.NA on x, right? X is a vector, 1, 2, 3, missing. And we say, what's missing in x? Or is it missing? Is it a missing value in x? Okay, 1 is not missing, 2 is not missing, 3 is not missing. The missing value is missing. And we get false, 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 true. All right? Okay. Oh, let me give you your first view quiz answer. Today's first view quiz answer is the letter D. D as in dog. D as in dog is your first view quiz answer. D as in dog. All right, let's try question 55. What command, or I guess, well, I don't know what line it is here on your machine, okay? But it says filter exercises, find all flights that had an arrival delay of 2 or more hours, okay? How would we write this, all right? And tell me how many flights would you get? So we're gonna use filter, right? And then, so sometimes you're like, I forget what are the column names I even have, okay? So a quick way you can deal with it is inside the console with a capital V, you type in view. View with one capital V, starting with a capital V view flights. Okay, capital V view flights. This will give you kind of like a spreadsheet preview, right? But this is just a viewing thing. You can't like make edits or anything like that. It's not like Excel, all right? And you can see the names of the columns listed across here, okay? So I think this first one, pretty easy. Arrival delay of 2 or more hours. Let me know when you think you've got the answer. And we'll compare answers by how many rows did we get? Okay, so you guys got it? Maybe compare with your neighbor. Compare with your neighbor. How many rows did you get? You did something, you need help?
Yeah.
So if you find all flights that had an arrival,
Okay, that's fine. Yeah. You've only run 12 or 13.
2 hours from now. So,
Yeah. So you don't have to highlight it. Just control enter.
I'm just still trying to do it. So, arrival. So that'd be arrival delay. So you're not supposed to do departure delay.
All right. So if you think you got your answer, compare with your neighbor. See if they got the same answer as you. Okay.
Filter lights. Arrival delay. All right. Good.
Okay. Is there everybody in agreement with their neighbor?
Yes.
Over here I don't see as much interaction, but that's okay. You guys compare? All right, so we're going to do filter. What do we do? Filter, and then what do I type? Flights, and then?
Arrival delay.
All right, how do I spell arrival delay? Wait, hold on. Let me check. ARR underscore delay. it's not appearing here. All right. ARR delay, what do I do? Greater than or equal to 120, right?
Yeah.
Ah. Okay, so I got 10,200. Is that what you guys got? 10,200? Yes? Great, thumbs up. Great, okay. Let's do the next one. Flew to Houston. There's 2 airport codes for Houston, IAH and HRU. 2 airports in Houston. How do we do this?
DES.
All right, so again, here, why don't you guys do the next 2? Flew to Houston are operated by United, American, or Delta. Get your answers, and again, compare with your neighbor. Compare with your neighbor. And you know what? If you're watching online, I know this is boring, so I'm going to just pause the video recording here. Okay, all right. I lost track of time. But so let's take a look. All right, what do we get for filter Houston? All right, we're going to do filter flights. We're going to set destination, and then we're going to do percent in percent is one of either IAH or HOU. Okay.
Oh, is it okay if we do?
Yeah, so hang on. Yeah. So here I got 9,313. Is that what you guys got? Okay. Now you could also do this. You could say destination equals IAH vertical bar destination equals HOU. Okay. And you'll also get the same answer. Now, if you're using the same variable, like destination here, this one, using the percent in, is a superior method, okay? Just because whenever you have a bunch of these things with ORs, like, it's a good operator, but it's also easy to make mistakes, right? It's easy to mess something up a little bit here, okay? And the one thing that will not work is this. You can't do destination equals IAH or Houston. That's often how we think. If I do this, what happens? Okay, I get an error here, right? I said, yeah, you can't do this. You can't do this, okay? So you can't do that. Question?
Oh wait, no, never mind. I was about to ask a question. I realized.
Yeah.
Oh, actually,
Wait, hang.
Like choose specifically.
Huh?
Percentage means like you want to choose this specifically.
Yeah, percent in percent says I want the value for destination to be one of these things.
Oh.
Okay. All right, and so similarly, the answers for this one, we'll do filter, flights, carrier, percent in percent, and we'll create a vector for UA, AA, DL. All right, I got 139,504. I don't know if that's what you guys got. Okay. Some of these other things. Okay. It's 9:45. Okay, I gotta fast forward. All right. So there were a bunch of things about like mutating for creating new. Maybe we'll spend more time on this. I don't know. I don't know if. Okay. Let me go back to these slides on group by and summarize. This is one of the tidyverse and dplyr's most powerful set of functions here. Okay. All right. Let me give you your last 2 view quiz answers before I forget. Last 2 view quiz answers for today are the letters C as in cat and E as in elephant. C as in cat, E as in elephant. All right, you guys got that? C as in cat, E as in elephant were your last 2 view quiz answers. All right. Yes, and now I've given you a total of 3. Right? You've given you a total of 3. Okay, so summarize. No, it's spelled with an S, and I think they also allow you to spell with a Z. Okay, but what a summary statistic does is it takes a bunch of numbers, shrinks it down to 1. Okay, that's the whole point of a summary stat, right? I say, hey, what's the average age in this classroom? Okay, rather than we take all of your ages and then we shrink it down to one number. We say, oh, the average age is 19. I don't know. Okay, I'm making that up. All right. What's the variance in heights? We take everybody's height, and then we get one number, variance. Okay. And same thing with all of these other things, right? You can ask for. So here is, we're looking at the Star Wars data set again. Okay. Star Wars data set, there's different values. You've got the height, you've got the weight, the mass, okay? And you can ask, hey, I want the average for the height. I want the variance for the height. I want the average or the mean for the mass. I want the minimum height, the maximum value, right? The count. All of these things I put in the optional argument, ignore the missing values. Because if I didn't put that, it would say, hey, we don't know, the height of whoever this is, right? Some mystery character. We say, well, we don't know this person's height. And then it would just say, well, we don't know the average at all because that value is missing, right? Anytime you have a missing value somewhere in there and you ask, what's the average becomes unknown, right? It becomes missing. So we say, ignore all of the missings, and this is what we have. So look at the structure. Of this command. It says, take Star Wars, we're going to pipe it into select the columns height and mass, and then from there, work with height and mass. We want the average height, the variance of the height, and we define how do we calculate the name of this variable. Now, these names over here, average underscore height, these are just arbitrary names. I picked these because they make sense to me, but somebody else could write mean height or something else, right? Mean HT. Average HT, whatever you want, okay? So we have that, and these are just different ways to get this, okay? And then what's the result? The result has just one row because it took all, I think there was 87 characters in the Star Wars data set. It just shrinks the whole thing down to one, okay? The next thing, though, is that the summarize works very well with this function called group by. You give it a categorical variable, like species, and then it creates groups, right? And it's going to take all of the humans, and it's going to group them together. It's going to take all of the droids, group them together, okay? It doesn't actually, sort them or anything like that. It just identifies. It's basically like color coding your data set, okay? But it happens kind of invisibly in the background, okay? So when I do this, and I say, hey, group by species, and then just give me these columns, name, height, mass, and species. It just looks like name, height, mass, and species. And then the only thing that's different from just a regular select and this thing after group by is that it says, hey, we found 38 different species groups. So now, look what happens here. I say group by species, select these columns, and then run it through summarize. And what this does now is it creates the summary statistics based on each group. And so here we can see in our data set, there is one member of the basilisk species. I don't even know what that is. Who's the basilisk in Star Wars? Who's the ultimate Star Wars fan and knows who's the basilisk species? We don't know, okay? But we have 6 droids, and the average height of the droids is 131. The standard deviation in heights for droids is 49.1. The average mass, the mean mass for the droids is 69.8, and the standard deviation of the mass for the droids is 51.0, so on and so forth, okay? So we have these different things, right? When you only have one member, there's going to be no standard deviation because you can't calculate standard deviation when you only have one. But there we go, okay? Because we have 38 species represented, we're going to get 38 rows. Now, what I can do now is I could say, you know what, I only want, so look at this whole command. It looks like a lot. And it is a lot, but I think it makes sense, right? Take Star Wars, group them by species. After you do that, select these columns. After you do that, create the summary statistics. After you do that, take the previous result right here, Filter out. Only give me species where there was more than one. Okay? Filter where the count is greater than one. I only want species where we had more than one instance. And then arrange them in descending order of count. Right? I want to see the most populous species here. So we got all the humans. There's 35 humans. Their mean height is this, etc., etc. There's 6 droids. This is what we got. We got 4 people of missing species we didn't know. 3 Gungans. I don't know who the 3 Gungans are. Jar Jar Binks. Jar Jar Binks' boss. Someone else was named, apparently. Okay, we got 3 Gungans in the thing, right? We got 2 Camino ones. I don't know. They apparently have names and stuff. And we're able to match group by and summarize. Okay, I think we're going to have to spend a little bit more time on this. Talking a little bit more about dplyr and stuff. These are some really powerful things. I've also went ahead and assigned additional data camp homework for next week. It's not due until next Friday, right? You got this Friday is the ggplot stuff. Next Friday will be dplyr stuff. But I want you guys to work on that. Okay, we'll end here for today, and we will see you guys on Friday.